Welcome back to the GCSE Maths Pro YouTube channel. In this video, we will be looking through iteration, but specifically the questions where they ask you to show how to rearrange the formula. So straight into it, this is an example of one of the parts of a whole iteration question. Normally it's about 2 marks, and they basically just want you to go, how do I get from the original equation to then the iterative formula? And we just have to kind of have a look at both of them and figure out what steps have they taken to rearrange it in such a specific way. So show that the equation x cubed plus 4x squared minus 5 equals 0 can be arranged. Sometimes they say arranged or rearranged, it just depends. Can be arranged to give x is equal to minus 4 plus 5 over x squared. Now this is the iterative formula. So it's normally rearranged in an odd way. They try to get x as the subject, but not necessarily in the way that you might think. So it's kind of helpful to have a look at both of them and try and pick out what they've done. So I think we're trying to get x on its own on the left, aren't we? That's the end goal. You can see that they have added the 5, haven't they? See how on the original equation, on the left, it's negative 5. On the right-hand side, it's now positive. So I could do that. So let's just move that across. So we've got x cubed plus 4x squared equals, and then just add the 5. So obviously it becomes positive because I've moved it across. So I've got that bit. Now we're kind of into the hardest bit. How have they been left with an x on its own? We've got an x squared still, even though it's divided, but there's no x cubed anymore. The next thing I can see is that I do have a minus 4. Now obviously the 4 comes from the 4x squared, doesn't it? It doesn't have the x squared anymore, but it has been moved across, hasn't it? Because again, it swapped the symbol. So maybe let's move across the whole 4x squared. So we're left with x cubed is equal to, I'm going to put the minus 4x squared in the front just because that's the order that they put it in the actual formula, plus 5. Now, how do I get x on its own? Because I know that naturally we would want to cube root. And the only reason why I wouldn't do that in this case is because there's no cube root in my formula. That's the only reason why. Otherwise, I probably would just cube root everything to get a single x over here. But what else could I do to leave an x over here on the left, just one x? It would effectively have to cancel out the x squared here by the 4, wouldn't it? Because the 4 is just on its own. And we end up with some kind of 5 divided by x squared. So I'm trying to kind of piece things together by looking at the starting point, the original equation, but also the end point as well. So I think what I would have to do, it doesn't feel natural, but what I would have to do just to make it match is I think I would divide across by x squared. Because you see how if I divide this by x squared, well obviously they would cancel, wouldn't they? Which leaves just the minus 4, which is what I want. And then 5 divided by x squared has to remain as 5 divided by x squared, doesn't it, as a fraction? So I'm going to divide across by x squared. So I've just shown a couple of steps. You could have also just jumped straight to this step really and moved the 5 and the 4x squared across. Doesn't have to be as many steps as this, but I was just trying to figure it out. So as long as you get to the exact same end point that they have, that's all you need to figure out. It doesn't feel like necessarily a natural way often of rearranging. It's more important to pay attention to what they've got at the end and just trying to figure out how can I get from A to B, more than what would maybe feel natural in terms of rearranging. Okay, so this is a very similar question. We've got show that the equation x cubed plus 6x minus 5 equals 0 can be arranged to give x is equal to 5 all over x squared plus 6. So this one, we can obviously see, I think the first obvious step is that the 5 again has been moved across, hasn't it? We've added 5. And then, if you have a look at the end result, they've divided by x squared plus 6. So on my left-hand side, where do I get x squared plus 6? Because I've currently got x cubed plus 6x. Well, that one, I would have to, and also I want to obviously leave behind an x, I would have to factorise it, wouldn't I? Factorise out the x. Do you see how then in my bracket, I have x squared plus 6? And then I could just divide by that bracket. So 5 over x squared plus 6. So you might need to factorise as well, which isn't always something you might think to do with rearranging. It's just figuring out how have they got that x left on its own, because it might be different for each question. Okay, this is exactly the same question, but it looks a little bit different now. So, show that the equation x cubed plus x equals 52 can be rearranged to give x is equal to the cube root of 52 minus x. So you can see here they have, this one I think is almost a little bit more obvious. They have actually cube rooted it, haven't they? So I think the first thing I would do is say, right, well, they've obviously subtracted the x, the one that was on its own. They've taken it away to move it across. So then we get the 52 minus x bit, which is inside the cube root. And then at this point, they have actually decided that they do want to cube root it. Sometimes they do, and sometimes they don't. You just have to figure out based on the question. So that one was a little bit easier. Now, my final question is worded a little bit differently, although it is only a 1-mark question. So, this would have been part of a question that had many parts to it, so I've just tried to condense it into one question for this video. We've got the iterative formula, x is equal to the cube root of 40 minus 8x, is used to find estimates of the solution of an equation of the form x cubed plus ax plus b equals 0. Where a and b are integers, we need to find the value of a and the value of b. And as I said, it's literally just 1 mark. So actually, this is kind of the opposite, isn't it, than the previous ones. We've been given the iterative formula. They want us to work back and effectively show how it can translate back into the original equation. So we're just doing the same thing, but opposite now. How would I rearrange the iterative formula to get everything on one side again? Well, the first thing, I'm obviously going to have to cube both sides to open up that cube root. So if I cube both sides, you don't necessarily have to write down this much working out, because obviously it is only a 1-mark question, but I'm just trying to over-explain it for you. So we've got this. Okay, that's great. X cubed, that bit's fine. But you can see everything is obviously on the left-hand side of the original equation. So I'm going to also move the 8x and the 40. So the 8x I'd have to add, and the 40 I would have to subtract, so just be careful of the symbols. So that's obviously the format of the original equation. Now, obviously they've said a and b. A is this one, b is this one. And because you see how in our equation they've put plus for both, so the 8 is obviously fine, isn't it? It's a positive. But just be careful, because the b that we have is negative 40. Because they have not accounted for that negative in the equation, my b is negative 40. I have to write down the negative as well. So that would just be 1 mark. As I said, don't need to write any working out really, because it's only 1 mark, but just in case you wanted to kind of visualize it, rearrange it backwards to get the original equation. So it's a really nice part B or part C question in iteration, just trying to figure out how do I get from the equation to the iterative formula, try and piece it together with the different ways that you can rearrange equations. So that is everything for the rearranging of the formula part of iteration. Make sure to check out the next 2 videos so that you know everything for iteration. Otherwise, thanks for watching this video. If you found it helpful, make sure to like and subscribe, and leave down below any questions or comments that you might have.